Hi, my name is Wouter Emery and I've been running simulations and wind tunnel tests to understand and optimize the aerodynamics of vehicles, drones, sports equipment, and so on. And today we're going to discuss the Oneshot Pickleball paddle airflow technology. Now, this may look simple, but it's actually quite advanced. This technology features four holes in the face of the paddle, four on the left and four on the right, which will help to reduce the wake and the aerodynamic drag so you can actually hit the ball faster. Basically, if you have a normal paddle with a fully covered face, what happens if you swing is that you drag air along in the wake of the paddle as you swing it. And this creates resistance. This is aerodynamic drag, which means that you'll slow down. For the same force, you will have slower movement with a high drag coefficient compared to when you have a low drag coefficient. So if you find ways to reduce the drag coefficient by adding these holes, for example, you can actually swing faster. And the way this works, and we'll look at simulation results later on, is that this paddle with the airflow technology of Oneshot features holes that will bleed air into the wake as you move the paddle through the air. So some of these holes will actually feed air into the wake, which reduces the size of the wake or the pocket of air that you drag along as you move through the air. And this reduces the aerodynamic drag coefficient by up to 2%. And this may not sound like a lot, but 2% actually can make quite a big difference in terms of sports, especially when things come down to a fraction of a second. Now let's have a look at some simulation results to see why and how this actually works. So here we are with the simulation results of two geometries that we have analyzed. The first geometry is a normal standard paddle, and I can show you this when switching to 3D view, is a standard one without the airflow technology. And the other one that we analyzed actually did feature the one-shot technology with the four holes on each side without any other differences between the geometries. So they're exactly comparable. So let's start with the basic paddle, which doesn't feature the airflow technology. And as you can see, as the air hits the front of the paddle, you have a very high pressure zone as the air comes to a complete standstill, which ultimately leads to the stagnation pressure. At the other side of the paddle, you have the opposite effect. You have a low pressure area because the air you're dragging along is trying to stick and pulling at the rear of the paddle, giving you a low pressure zone. And the delta between the high pressure at the front and the low pressure at the rear is creating the aerodynamic drag that you feel when you swing it through the air. And this is what slows you down. Now, if we first look at a slice, we can get a better understanding of what is happening as the paddle moves through the air. So what we can do is actually zoom in on these results to see how large exactly this wake is. In black, you can see the streamlines, and as the air hits the front face of the paddle, it needs to splash out left and right, or top and bottom, whichever way you want to see it, to curve around the paddle. But it gains so much lateral momentum, left and right, that it's impossible for the air to make this sharp curve of 90 degrees around the paddle's edge to actually close the wake sooner than you would like it to. So what happens in reality is that it splashes out and needs quite a lot of time and distance to curve back inwards. And in the process, this creates a very large wake behind the paddle. Now, if we look at what happens if we slice through one of the, let's call it ventilation or airflow technology holes in the one-shot paddle, we can observe something very interesting. So if we zoom in on this area, we see that the air doesn't necessarily need to go to the full outer edge of the paddle, but it can already make its way to the wake via this channel or one of these four ventilation holes. And this gives you a great pressure relief at the rear of the paddle because the air curves inside and uses this semi-curved inner part of the edge guard to create a curved trajectory for the air to get into the wake. And as you can see, this helps to feed the wake. This is yet another small area of the wake that is being filled with fresh air, which reduces the pressure drag on the paddle. So if you zoom out again, you can see that this creates a swirl here of fresh air, which reduces this low pressure zone locally, which again reduces this aerodynamic drag. And if we switch to 3D view, you can also see this on the pressure map. So if we zoom in again, it's the same geometry, but with the holes, with the airflow technology of Oneshot. You can see that the pressure relief is the same as with the normal paddle. As you get close to the edge, the air accelerates and you start to get some pressure relief. This also happens around the holes. So there's two effects playing. One effect is that you just simply have a lower frontal surface area, and this lowers drag. And you also have this pressure relief effect around each and every one of these holes, which reduces the wake and the aerodynamic drag. So this is in short how the one-shot pickleball airflow technology works. I hope it was clear. If you have any questions, just contact the team at One Shot and they'll be very happy to assist you with any questions that you may have. Good luck!